Hello, everybody, and welcome to our talk today. We'll be talking about low-code Apache Airflow. And we talked about low-code Apache Spark yesterday. Let us first start with our introductions. I'm Raj. I'm the founder of Prophecy. And before this, I worked in compilers at Microsoft. I was one of the authors of CUDA at NVIDIA. And then I worked in databases, first as an engineer, and then I was the product manager of Apache Hive at Hortonworks. Saw a lot of data engineering, and now Prophecy is focused on making data engineering very easy for everybody. Also with me is the co-founder, Machik, and he's an expert in Spark data engineering, Spark expert in Spark machine learning, and he'll be doing the demo today. So as we look at low-code Apache Airflow, it's all about making Airflow super easy to use, right? So this is something that's a new feature. We are presenting it for the first time. So yesterday, we talked about how data engineering is just too hard and too slow. How, in development, standardization is hard, enabling a lot more users and making them productive is super hard. Today, we'll be focusing on metadata, right? And for most of the people that we work with, metadata search and column level lineage is not something that they have, on Spark. So what are the use cases, right? So typically, if you're in data engineering, let's say you have a governance need and you have social security data in one data set. And perhaps you have 10,000 workflows that are moving it to many, many other data sets. So now you want to track, right, this column, which all other data sets did it end up in? And column level lineage helps you do that. Or perhaps you are changing a particular column. You're saying, I'm removing a column from a data set. What you want to know is that other teams, other projects that are downstream, is one of them going to get affected, right? So you want to do impact analysis, or perhaps you're a data analyst, right? And you're looking at a value and you're saying, hey, how was this value really computed? You know what the definition is, but you want to know it was computed correctly before you make a decision on it. So for all of them, these use cases, column level lineage is super critical. It's something that, most of the people we work with want and don't have. So we'll show you how we do it and give you a demo of this. The second thing we'll dive into is scheduling. So now, scheduling, Apache Airflow is good. It gives you a lot of basic primitives for scheduling, but scheduling on top of that is still very, very hard. And as an example, we work with some Fortune 50 companies. Some of them are like, okay, I am moving 20,000 workflows to Databricks. How do you want me to schedule them, right? It's like, should I write 20,000 schedules manually, right? So you run into these problems of how do you write that many schedules? How do you deliver them? Make sure each one has the latest version of the workflow. If something fails, how do you recover? How do you monitor them? And perhaps there is cost optimization, right? Because if you spin up one cluster per workflow, soon you'll be just spending all your time spinning up and spinning down clusters. So we will give you a demo of low-code development of Apache Airflow and tell you about some new things that are coming right after. So, as we mentioned before, if you're a data engineer, you have use cases of impact analysis, understanding, or you're a data analyst, you want to understand the value. If you're a metadata architect, you want to have PII information and so on. And these goals require a few features, right? So first is automated lineage computation. What that means is that if you have your code, can the lineage be automatically computed from there, and can it be stored? So it's a place where, if you have a metadata system that's separate and says, hey, you have to use these API calls to add lineage, you're never going to be up to speed. So automated computation is super important. The second thing is it needs to be multi-level. So you might say, I want to look across data sets and workflows across projects. And then once you are within a workflow, you might want to dive in, and the workflow can be very big. So you want to pinpoint exactly where the change was made. And finally, you want to be able to search, right? You want to be able to search by columns and say, where all is this column used? You might even have a user-defined function, and you're like, where all is it used in all my workflows and data sets, right? So you can search by authors, by columns, by even use of functions and expressions. So we will give this as the second demo. Now we'll move on to low-code scheduling. So low-code scheduling is basically where you can use visual drag and drop to build Airflow workflows very, very quickly. So first focus is it has to give you rapid development. That means you can do quickly, you can do drag and drop and enter only the essential values. Everything else is automated. Number two, what about the deployment, right? So let's say you've deployed into a test environment, into a production environment, and a workflow changes. Now you have to rebuild the jars, redeploy the jars, right? So there has to be automated deployment, but it also has to be automated where all new redeployments can happen without any manual intervention. Finally, once you have done, okay, you're able to develop, now you're able to deploy. Finally, you have to monitor. And when you have to monitor, you want to be able to browse all your deployments, all your runs, and see what's working, what's not, what is delayed, and perhaps later, which of the parts are the ones that are taking most resources. All right. And now, just before the scheduler demo, I want to give a quick summary of how Prophecy works with your infrastructure. You have your Git, you have your shell, you have your Spark, your Airflow. So you have your infrastructure, which you are using currently. Prophecy adds a data engineering system on top. Of course, you're getting the low-code Spark development, but the code is, and the test, the lineage, everything is going on Git. Now, we talked about this yesterday. We showed you a demo. Today, we are focusing on Visual Airflow Editor, right? So you have a low-code Airflow Editor where you can similarly use drag and drop to create Airflow schedules. The code that you're creating ends up on Git in completely open source format. So it's 100% open source code. It's in Python. It's exactly as you would handwrite it. The other thing we provide is you can just connect to an Airflow cluster and interactively run and see the Airflow schedule running live. You can see the logs as it moves from step to step, something you cannot do with Airflow, without Prophecy. So we'll show you a demo of that. And finally, we'll show you a demo of metadata search and lineage, how you can search across all the columns, the data sets, and also we'll show you lineage, how you can track values across your entire data engineering system. Now, the one thing that we also showed you yesterday is Gem Builder, which means that for Spark workflows, you can use the standard library, which is what we provide as the built-in gems, but then you can build your own. This is something that is available, for Spark today, but will be available over the, in the next 2-3 months toward the end of summer on Airflow as well. And of course, for Spark, we support both Scala and Python. For Airflow, it'll just be Python. All right. And now, if you don't want to worry about any of these details and you just want to use a simple low-code system, you can use that and not worry about any of these details and make yourself more productive. With that, let's move on to the demo. In the demo, we'll talk about schedule development, low-code Airflow development, where you'll use drag and drop to build Airflow workflows, and then see how you can run them interactively and deploy them to Airflow for production. Also, we will do demo of search and column level lineage at the end.
Hi, everyone. Thanks for coming. Yesterday, we have shown you how to build a complete end-to-end data engineering pipeline directly in Prophecy in under 5 minutes. Today, what we're going to do is take that pipeline and schedule it using Prophecy's low-code Airflow scheduler.
So here we are again. This is the metadata screen where we have our project that we have created yesterday with the workflow. We can look at what transformation the workflow has, of course. That's how it looks like. But actually, let's go ahead and create our schedule right now. So we can just create new customers schedule and open up the IDE. And there we go. So we start, of course, with a white canvas on which we can now start drawing our schedule. So we have all the gems right at the top that are representative essentially of the Airflow operators, and we can use them to build our schedule. What we would like to do is to actually take some files from S3 directory whenever they show up and run a Spark workflow on them. Once our Spark workflow finishes, let's clean up the S3 directories and send some email notifications. So I have here this S3 directory ready. It contains the source data directory, which is empty, and this target data directory, empty as well. So without further ado, let's actually get to creating our schedule. So we can start by dragging and dropping our sensor component. Let's open it up. Let's make sure it's connected to the right path. Now, this sensor component is essentially what's going to be doing is just going to be querying our S3 every 10 seconds and making sure that whenever files show up, the next operator runs. Okay. Awesome. Now, after that sensor runs, let's drag and drop our workflow gem. That's going to trigger our workflow. Let's pick our customer amounts workflow. And for now, we're going to be executing this on the EMR cluster. Of course, Databricks or other Spark environments are supported. And we can additionally provide some workflow configurations. Now, after that workflow runs, let's actually go ahead and run a simple script that will clean up our S3 directory. So I have here a small snippet that will just iterate over all the files within the source data and delete them one by one. After that script has executed, I would like to, of course, receive a success notification. So just drag and drop the email gem and fill it up. Cool. Then, of course, alternatively, if our workflow doesn't succeed, we would like to receive a failure notification. So we can just set up our gem to be executed only if the previous task fails. And let's write up our failure email. Okay, so just like that, we've built a complete schedule in under 2 minutes. What we can do right now is just go ahead and actually check whether the schedule does the right thing that we intended it to do. To do that, Prophecy provides a debug functionality for Airflow schedules. So essentially we have this small play button at the bottom corner. We can click that. That will generate the code for our DAG, put it on Airflow and schedule it just one time. While this is happening, of course, we'll be seeing logs showing up in real time for every single step. So we can see that right now our jar is being built. After that, the DAG file will be created. It's going to be transferred into Airflow and our components will actually start executing. The alternative mode, of course, is that after we have finished with our debug run and we know that our schedule actually works, we can put it in production. And just with one click, we can deploy the complete Airflow workflow that will run all the CI/CD steps, place this Airflow code within our release branch, build the jars for it, and of course, make sure that it runs within Airflow within the set timeframes that we can, of course, configure within our configurations. So we can set all the start dates and the intervals directly here. Now, Prophecy IDE, of course, is not just a visual editor. Behind the scenes, there is always a high quality code that you can just take and edit. And so we can just click on this code button directly here, and we see the DAG code for it generated. So this is our main.py file that actually creates the definition of the DAG. It sets up all the operators, which are just simple functions. We can, of course, inspect all of those functions as well. So this is our check file, which creates just a S3 key sensor within Airflow, some email notifications, just email operators, and of course the Spark run and the cleaning data steps. All the configurations and other scripts are directly placed right within this directory as well. Now, going back to our visual scheduler, what we can see now during this interactive mode is that our sensor has already started executing. So if I hover over this icon, now I can see that it is running and I can see all the logs being available to me right here. So I can see that it's already poking this S3 directory. So let's actually go ahead and place some data there. So we can open it up. I have here a directory ready. Just drag and drop the CSV file to it. And that's the CSV file that our schedule should now pick up. So let's go back to the IDE and we can look at the logs, what's going to happen. So now we can see that just within a second, this sensor operator has finished successfully. We can see all the success logs. That component has been now ticked. meaning that it has completed, and our workflow has started. So now the workflow is spinning, and we can see that it has actually been already submitted to the EMR cluster. And the job status should soon turn into pending. So now while this is running, of course, all of this code that we have developed within the Prophecy IDE is also visible on our GitHub that we have set up yesterday. So this is my Summit session repository. If we just refresh it, we can see that now there is this schedule directory that was created 4 minutes ago. We can open it up and see our main.py file directly here and all the other code dependencies, like our graph files, and so on and so forth. Now, of course, once you have many different schedules working in production, what you would like to do is also monitor those schedules and see how are they doing. Doing that is very easy with Prophecy. We can just open up our metadata again and directly from here switch to the deployment manager. Deployment manager shows you all the schedules that you have created that are currently scheduled and running, and you can monitor how well are they doing. So here we have some 2 other schedules that were running for already some time. We can see that some of them are doing well, some of them have failed, and we can see which workflows they've run and the historical runs for them. Directly from here, we can jump into the Airflow UI if we want to inspect any details, like see the code or check out the Airflow views. But of course, everything is contained within the Prophecy IDE itself. So if I want to inspect each run, I can just go to the Run tab and see each run, all the dates for them, when they were finished, started, and also the logs. So I can quickly check what went right or what went wrong. Now let's go back to our IDE. Oh, wonderful. So everything here already has finished. We can see the logs for our workflow that has already successfully completed. After that, our script has completed and one success notification should have been sent. The failure one did not complete because it was skipped, as we can see here. So let's actually open up my Gmail account. And we can already see that just a second ago, I got an email with our workflow has finished notification. And we can also see the S3 directory and how it's changed. So now our source data has disappeared and our target data directory contains the actual results of our Spark job. Wonderful, so our schedule has completed successfully, and in just under 5 minutes we've built this production-ready schedule that looks through the S3 files, runs our workflow, and sends us appropriate notifications if something goes wrong. Now, taking that the next step further, very often your organization will have many different workflows and many different schedules running at the same time. They're performing tremendous amount of transformations and operating on hundreds or even thousands of columns. What do you do then, right? How can you inspect your transformations? How can you make sure they're all correct? Well, for that purpose, Prophecy provides the Lineage functionality. I'm very excited to show you as well. So we have this project set up here, Spark Summit demo, which has 2 workflows and few data sets, which those workflows are processing. Now, normally to understand what's going on here, you would need to dive into the code, see what the Spark read operations are, what the Spark write operations are, and figure out from the code what's actually happening there. With Prophecy, however, to inspect what this complete project is doing, you can actually just click on this small lineage icon directly within our datasets and jump within the lineage view. That immediately shows you how this dataset is being created, how is it used, and which workflows modify it. And of course, I can just keep jumping between datasets, just like that. I can see how they're being created, what they use. All of that is tracked within the history on the left-hand side, so I can just go back and forth. I can inspect, of course, the columns of each of my data sets. You can see them right here. And if I would like, I can actually select a particular column and see how it's being transformed. So if I, for instance, select the last name column within my customers dataset, I see all the transformations right here. In this case, just downstream transformations. I can see this column is being changed because it's highlighted as red within this customer amounts workflow, and it is being written to my report. I can actually deep dive into this workflow and see how it is being transformed within it. So I can open up any of the components and inspect the code right here. The code is also automatically highlighted for me so that I know exactly which pieces of code are performing the transformation. Now let's go back a little bit and let's think about two different examples when Lineage becomes tremendously useful. One example is, for instance, when we have some PII data within our data sets, right? So a very common example, there is a tremendous amount of customer data that you would not like to reveal or store in particular data targets. Right now, within my customers data set, I have here this customer SSN column. To understand how it's being used and when it's written, it's as simple as just clicking on that column, and I can directly see that it's being written into my customer SSN dataset. It is not, however, being written into my report. That's great. So downstream users won't be able to see it. And it is not used anywhere else. I can also inspect the actual workflow, see how is it being transformed, if at all. And I can see that there is no transformations applied on my SSN column. It's just a simple pass-through. Cool. That will make the life of people who are checking the compliance and ensuring the workflows work well much, much easier. The alternative example is a much simpler debugging example, right? So as a developer, I have many columns that I need to make sure are correctly transformed. For instance, if I have a column amount that I would like to understand how it's being created, now it's as simple as just going to any particular data set that I think might contain it, choosing that column, I can see how it's being modified. So I can see that on the upstream, the amount column is just created as a sum of amounts. There is actually another sum that's going on in the downstream, but I can just click into the workflow and inspect that right here. And I can see that there is an aggregate sum amount. Now that allows me to much easier and quicker debug through complex data pipelines. Okay, so with that, we've just shown how easy it is to build complete schedules with low-code Airflow scheduler within Prophecy, and how easy it is to understand your complex data transformations with Lineage. Back to you, Raj.
Thank you so much for the demo, Magic. All right, so we saw how easy it is to do entire low-code data engineering with Prophecy, right? You saw low-code development of Spark workflows. Now you've seen low-code development of Airflow workflows and also for metadata. Also, you can see that all of them work well together, right? So with that, we want to talk about one more thing, which is a roadmap item. Tentatively, we're calling it Scheduler Gen. And this is something where we've had a lot of, like we said, we work with the Fortune 50 companies. And the problem that we run into is this, right? They have 10,000, 20,000 workflows. They come to us and say, hey, do you want me to write all these workflows manually? And you already know what data sets each of the workflow is reading, what each one of them is writing, and so on. Why do I need to tell this information again? And what about cost management, etc.? So what we are working on is that, of course, from the workflow, since we have Lineage, we can extract the plan, right? The plan that you see in the middle has data sets, which is being read by a workflow, then that writes a data set, the next workflow picks it up, and so on. So you can see all your workflows in one place. Now, once you do it, right, you cannot spin up one new cluster per workflow. You're going to spend a lot of money just spinning up and spinning down clusters. So now what we can do is we can be very smart and segment them and say that, and here you can see, the purple ones, the green ones, that we've created 3 different segments. And in one segment, all the workflows are going to run on a single cluster. When creating these segments, we are going to consider the size of the cluster, the amount of time taken, and making sure that we meet any SLAs that are possible, that we need to meet, right? So now, once you do that, once you've done these segments, from these segments, we can generate Airflow schedules, which says, run segment 1, run segment 2. Of course, if something in segment 1 or segment 2 fails, you have to be able to restart from the middle. So there's complexity there. Of course, you also need to have all the different workflows packaged into a single binary to be able to run on a single job cluster. So this is something that we are actively working on. If you want to, we're looking for design partners. We have one. We are looking for some more. So if you want to try this and make sure that this works for you, come talk to us. We'll work with you. Make sure that we can, over the next 3 to 5 months, build this with you and make sure it works for you. So with that, as a summary, again, Prophecy provides low-code data engineering, which makes it super easy. Each one of the pieces works very well with each other. It makes the users very productive on Spark, on Delta, and also on Airflow. And the code that you generate is standardized and standardized on the standards you want, not just what we provide. And you can be agile, use Git, CI/CD, and all the modern software engineering practices. And finally, as I said, the complete solution means that you are not stitching together your own solution from the parts, but get a full product. With that, we are really happy to take questions now.